Polaroid photos capture moment in time, but over time, they often deteriorate and fade. I remember my grandmother's Polaroid album. It's filled with irreplaceable and, in fact, immutable memories. But over time, they lose their original beauty. Polaroid photos are sensitive to light, humidity, and temperature. Before we delve deeper into this, I think it is paramount importance for us to define the problem coherently. Polaroid photos are highly vulnerable to fading and damage, which complicates their long-term preservation. First of all, I will tell you how a film camera works. When you press the button, the camera quickly blinks by opening a little window called a shutter to let light inside for just a tiny moment. The light from the thing you are taking picture of comes through the camera lens like how your eyes see things. The light hits this special film which has layers that can remember different colors like red, green and blue, but you can't see the picture yet. It's like an invisible memory waiting to show up. Now, we will go through a different layer of the film. The first layer is the scratch resistant. Imagine you have a photo and you don't want to get it all scratched up. So scratch resistant is the top layer that shields the film from getting scratched, so it stays nice and clear. The next one, we have the emulsion layer. This layer is where all the magic happens. This layer also contains silver halide that are very sensitive to light. It holds all the chemicals that make the image show up. Then, we have the adhesive layer. It's like glue. It's like also holding your sandwich together. Next, we have a base layer. It's a strong bottom layer that holds everything up and also make the photo sturdy. The last one is the anti-halation layer. This is a fancy way of stopping the extra light from bouncing around the picture and making it look blurry. It's like wearing a sunglasses when the sun is too bright.
Since Polaroids are associated with the preservation of film, challenges such as UV light and humidity needs to be restrained. Originally, the layer of the film has no protection against sunlight. We decided that the best way to overcome this problem is by pre-injecting UV stabilizers into the emulsion layer. Example of emulsion layer includes hydroxybenzophenone. Hydroxybenzophenone acts like a shield that jumps in front of the emulsion layer and base that protects them from the UV rays. It catches the rays and stops them from causing damage, ensuring the film's color is vivid and colorful for a long period of time. Here comes another challenge in preserving film, which is humidity. By adding moisture barriers beneath the emulsion layer, it serves as a protection against moisture even after the scratch resistance is broken. Adding moisture barriers and UV stabilizers into the film enhances the film's durability and image preservation. Moisture barrier blocks water vapor, preventing chemical degradation and also enhances the film's lifespan. UV stabilizers protects against ultraviolet radiation, reducing fading and also ensuring long-lasting color accuracy. These enhancements improve the film's overall reliability, preserving memories with minimal environmental impact by reducing the need for replacements. Together, they ensure superior performance in ensuring film's quality over time.
To wrap things up, we have seen and identified how Polaroid photos can degrade and fade over time, and our objective is to find prospective solutions that can enhance the longevity of these images. This work is important because it helps us keep our special moments alive for future generations to enjoy and remember.